Hello and good morning. Let's continue where we finished off yesterday. I'm still doing some stuff with my gearbox. And today I want to see if I can prepare this to let it run on a different workstation. And I want to have some changes here and there. By the way, I updated my background removal tool, and now the whole arm of the microphone is now gone. So that's very neat. Thank you, corporation, for that. Not making uh, not making advertisements for other companies here. So this is our simulation here. I just saved the view because we might want to return to this later. So let's see. Where was I? I want to focus a little bit more on the simulation. This looks incredibly complex right now, but to be honest, you don't see too much of the simulation itself. And the ISO surface is crap because we have a low resolution in the particles. For now, we are gonna change that later. But let's maybe focus on the stuff for the simulation today first. So I'm gonna put the rest away, but I want to take a look first what I can carry over from this. So the thing I want to do is I want to make a glass housing and basically show nothing but the gears, and everything else should be invisible. So I maybe should duplicate my scene here. So let's set it like this. Oh yeah. So we call this studio scene now. SPH feature focus. And we can close the other one. So what we do need in here. So let's first get rid of what we don't need here. So sorry, racetrack, but you're gone first. So here we go. That's our gearbox. And let's get away the clip. We might not need this today. From all the things I can see here, I don't want to see the wheel. So I'd say we remove that part. Next is the rim. I don't see an issue. I don't see a reason to keep this. So we remove that part. What's next? The wheel nut. Remove. The thing is, if I hide the whole carrier, I don't know if we will directly look into the inner stuff. So let's just hide it for now. And yes, it works as the housing. That's bad. That's bad. We might need a little housing here and there. But yeah, we don't need that one here. We don't need that one here. Oh, it's part of the rim actually. Cool. So That looks important because that's a part of the carrier. So we just say hide for now. We don't need the bolts for the wheel. I'm wondering if this is still the same design as it was in back in my days. Oh boy, now I sound really old. We remove that. Oh, we just have hidden the bolts, right? We did not remove them. So let's see what has been hidden. Ah, yeah, that's very helpful. Upright is hidden. Nothing else. What's hidden in carrier? Yeah, the wheel bolts. So let's remove the wheel bolts. So we take nothing and hidden. So let's... Oh no, I wanted to hide this one. That one's right. But I wanted to get rid of these here. Hide. I did it again. I wanted to remove them. Skill issue. Early in the morning. Remove. And we say bye-bye. Okay. Let's see if we maybe can grab something from our region. When we say, no, no, we cannot. But maybe we can set a clip here. You know what I mean? Let's deal with that later. Let's do the simple, obvious things. So this one is getting removed. The shaft. Okay, the shaft we hide for now. Because otherwise there will be a hole. We select these things here. And remove them. Of course you didn't need that one, right? What's that? These two are the same thing? Okay, then let's just hide them. Okay. No one needs that plate, I hope. Suddenly I noticed that a gearbox is fairly complex. Oh, come on. Oh, come on. I go into rest. See what's in there. Maybe we can deselect something from here. Radial ceiling. Upright. O-ring. Composite. Yeah, we don't need that one here. Looks better. The issue that we are struggling with a little bit is that there are a lot of things that's actually working as a housing but not really is a housing. So let's just switch it to, yeah. Is that part of the carrier here? Looks like it should be. Wheel hub input. This should be part of the carrier, if I'm not completely mistaken. Maybe we did something wrong here. Let's see. Carrier unite. No, wonderful. We united it. Perfect. So it should be in carrier, right? So I guess we need to duplicate the carrier for now. Oh, we need to show the motor shaft again. But we turn it into glass. So we can actually look through it. And the carrier will be glass as well. Maybe. Or maybe it should not. Let's keep it like that for now. So let us make the carrier a little bit easier to look through, because that looks fairly complicated. What happens if I now enable the particles again? Not really satisfied with that yet. So the fat golden things need to be gone. I will switch the planet into constant. Okay. I did not want to. Let's switch it into stainless steel for all. Okay. Making the view a little simpler. So let's see. I think that's already nice. But it's time to highlight the actual feature, I think, that we are putting in that simulation here. So I go for continuous physics and I say adaptive particles here. Then my criteria are gone. Really? Oh boy, please tell me that I still have the criteria somewhere. Oh boy. Let's look on my backup stuff. Yeah, here we go. Could be this one. Let's try this one. So let's go for this. Very good, very good. Continua physics models. Yes, we have the adaptive particles here. Can we copy them? Hopefully. Can we paste them? We can. Cool, 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 cool. So let's save this for now. And let us restart the simulation. Physics conditions. No physics values. Let's see. Let's make it like that. That's actually the particle size. So these ones were 1 millimeter. And I have just set it to 0.4 millimeters. And let us try how this will work. We save this. We clear the solution. And we need some more parts. And we need to make this a little bit more clean. That's already annoying me. New shape part, cylinder. Create close. New composite part. Nope, this one here. Cylinders. Cylinders. So let's put them here. Duplicate. Now let's first make the first one. So this one we need. Oh, and I just noticed that in the carrier we might wanna. Oh, come on. This should be glasses, clear glass shell. Yeah, that's actually very nice now. Now you can see that there are parts moving, maybe later. But let's get rid for them for now. So, where were we? We have cylinders and we want to, so 0, we need to have these coordinate systems. So planet 1 Thesis Cartesian 1 it is. Planet 1 Cartesian 1. Here we go. And then we had 20 millimeters in that direction and 14 millimeters. No, is it 14 millimeters? No, it's 20 millimeters in that direction. And yeah, let's do it like that. So it's 0, 0, 0, 0.02. And this was 0.014. Like that. Then we need the other one. So we duplicate that one here. We call that one small. The small one. This is the big one. So the big one needs to be same place. From 15 to 30 and 27 in diameter. So let's do 0.027 and 15 and 30. I hope that's correct. I think it looks correct. Okay. So we duplicate them now. And we duplicate them again. And we made a mistake. But that's fine. Big 2. We did not make a big mistake. It's just for my order. I would have loved to have them in order: one big, one small, one big, too big, too small, and so on. But obviously we made that wrong. So it's like that. And now what we are doing here is we're not positioning them differently elsewhere. We just take the other coordinate system. Ta-da! And it's at the correct place. How could that be? Wow. Awesome. Let me position myself a little bit more in the center. But maybe not so you look at, don't know, East Coast Standard Time or whatever this machine is on. So, here we go. And now we can visualize them. Okay. So what we're doing here is basically we are duplicating. We are making a little bit more order. So we do this 10, no, 11, 11, 12, and 13. And now we duplicate this displayer. And we say 21. 21 planets. We just call them cylinder for now. 22 cylinder is as well cylinder, and 23 cylinder. And for parts, we say nothing. And now we say for this part here, we say cylinders, the big one and the small one, not the curves. Cool. Same with the next one. Parts. Cylinders. Big 2, small 2. Too small. The curves go away. And number 3, please. Cylinders, big 3, small 3. Curves gone. Curves gone. So, what we're doing now is we're making them transparent a little bit. We need 3 colors for that. I want to have them colored but transparent. So I don't actually know. There's so many ways that we can do this. We can say geometry colors here. And then they are all gray. Let's do it like that. And then we go and select some colors. So first one. Well, we should select the same color for all actually. Maybe. Let's select a common color. Let's do this for now. Ooh, that's maybe a little bit too much for this morning. I like it. Deep pink, that sounds nice. So they have a very metallic look now. We are going to change this. We are going for glasses. Shells, please. I have an issue here. See this one here? It's at the exact position of the other face. So what I'm doing here is I will increase the position just a little. Small one. Make this just a millimeter taller. Didn't change nothing. Cool. Very cool. Very, very cool. Ah, I changed it in the wrong direction. So let's go like minus 0.1. Oh, that's way too much. That was 10 millimeters. What was I thinking? Yeah, that's better. That's a little better. Minus 0.1. Small 3. Minus 0.1. Like that. So how is it on the other side? That's perfect. But I think the colors are too strong. So maybe set the displayer to more transparent. Like that. What happens if I put the other glasses on top now? We can still see it. That's very good. But to be honest, I don't want the carrier to be glass. I want it to be plastic, transparent, acrylic. Ooh, no. We can't do with that. We cannot work with that. We go back. Maybe we could do for the other side. For the rest. No, let's keep it like that. Okay, so we have done that. We can save our work here. And we can now initialize our simulation. Hopefully. Can we see something actually? So it's like 6 million particles right now. And I don't see a thing. That's unfortunate. Ah, no, I do see a thing. I do see a thing, but I'm totally blind because the stuff is already here. Cool. So carrier we can show. Rest we can show. So, okay. We are going to duplicate this displayer for now. Hide that one. And we select a different field function. SPH particle size. And we select a different color map for that. Let's try this one. No, that does not work. Doesn't even show the color map. Bad. So let's put the legend in here. Millimeters. Where's my legend? Ah, there's my legend. See? I'm in front of the legend. Okay. So now I can see my particles. My particle size. But what I cannot see, I can't really distinguish the particle sizes. I don't think there's a medium particle size at that point. Just two sizes for now. That's interesting. And it's not what I wanted color-wise. So let's see what we can do for the colors. We don't have the medium colors, the medium size, right? So let's make a 3 color bar out of the Siemens stuff, shall we? Edit Siemens 3 discrete color levels. First of all, this one needs to go. because we cannot see. Then this one needs to go. This is basically Siemens color. We delete that one. And we delete that one. We put that one in the middle. 0.5. Let me just reselect that color here. So what we're doing here is we're making these colors like that. So we have 3 discrete sizes. I don't like it. I don't like it. These are clearly 3 different sizes, right? But somehow it does not show in the colors. Ah, yes. Because I'm dumb. We need to go for log. And it's still not working. Damn. Ah, here we go. Now it's working. Yes, we have 3 different color levels. Whoop whoop, what a great achievement. And it looks nasty. It does not look nice. I'm not happy with that. So, what shall we do? We go back to this and we start anew. We edit a copy. Or maybe not. Let's see what else we do have in store. Not very nice. That works. But it's really dark. That's actually a view I want to see exported. That's something I really want to see. When the gear starts splashing into that. Yeah. And once this happens, I want to zoom out and then see more of the whole setup. So we store that view. Oh boy. Begone, legend. So we really should make a new history for that. SPH adapt save. And we should put in here not lossless. We're working with off. Going full blast. Functions will be size and velocity, lab magnitude. So did we save the view? Yes, we did. So let us make another screenplay here. A new screenplay for the existing scene, which there is SPH feature focus. We say the director 60 frames per second. Don't know why this isn't standard in 2025, but okay, it's a choice. It's a choice, I guess. Or I don't yet like the color of the oil, to be honest. I want to work on this one. Here we have an oil dry copy, which I will use to adapt right now. So I think it just looks too dark, and I think that needs to be changed. So I'm looking into the materials, into the rendering materials for studio, because we're in studio environment, as we always are. And we have a color here that does not really influence anything. Here we have another color. That's the attenuation color. So the strength is this is the strength of the light that gets absorbed when the light travels through these spheres. So let us see if we can grab a color from our Siemens blue shade, of which we added a copy. And we say bye-bye. No, we don't say bye-bye. We say 25. 25. What? No. Damn. 5. So this one goes to 0.75 now. So we have a little room at the top. And we can make this a little more lighty. So what about this? Yeah, we can't see. And we will use this color, which should be in the palette now. Oh, for safety reasons, we copy the color code. We say okay, and then we go back to our materials and say, let's have that as an attenuation color. Maybe. Does it change anything? Maybe, maybe not. So, I don't like that. It looks... I'm not sure if I already do like that, but... maybe this position is actually better. Or maybe like that. View. View. Let's make it upwards. Yep. Like that. Maybe. And now we can drag and drop this into our screenplay. And we say camera. We say 0. And then we say, what's this for a view? That seems feasible. So we apply that value here. And we had another view, which was that here. So let's see how it looks when we go. Yeah, that's fine. I like it. We can work with that. So let's clear the solution again for now. And let us do a few iterations. Are you sure about that? Okay, let's stop it here. And let us see how the stuff looks. Do we see any movement at all? I don't think so yet. I guess we need a few more iterations before we actually can see movement in the stuff. We are looking at the particle size, so we don't expect any changes here. That's fine. If we did not look at the particle size, but at the velocity, by now we would see changes. Oh, it's getting green here. Right. So I guess I will just record this as it is and be happy with it. Yes. And once it's done, I will put my screenplay here. And the camera movement is way too fast. I will make it 5 seconds. And then I will put my solution view here and say, you, good sir, will be starting, you will be called states index. You will be starting at 0. You will be 10 seconds long. And because you are 10 seconds long, you will have 599 states. And so we will loop through these while we move the camera, and then everything moves here, and it should be fine. Of course, we have to set the transforms to the recorded representation. Yeah, but that's not an issue. Cool. And once it's done, I will look if we want the cylinder is here to rotate or not. Yeah. Ah, look, the magic is happening on the other side. Yeah, because the teeth are coming out here. Oh, stuff is moving through here in the beginning. So is it maybe the wrong side to start? Yes, it is the wrong side to start. But we don't have teeth here. So let me just go to the very first camera position. This camera position here. What if we tried to mirror that? 001. They should be 001 as well. And for my own sanity, this will be 001 as well. So let me just see what we can do here. So we are looking at hopefully some center point. So Y is that direction. No, this is, yeah, this is Y, hopefully. Z is that direction. Okay. What if we reversed this one here? We are looking definitely on the other side. We have kept the height, but we need to work on this more. Yes, that was completely wrong. So I guess it was something like this, 3.8. Okay, cool. So we are back at the position. So what we should do is change this position because we want to go to the other side back here. So we are looking from -14 to -13. So if I change this to -12, we should be on the other side, more or less. Ah, damn it. Or let us try -122. Where are we now? I don't get it. Is it too early? Am I too dumb? In general? Can we have more like even numbers here? Let's... Hey, we are moving in the right direction. Where are we now? Yes, it's moving in the correct direction. Perfect, perfect. Almost there. So now is the question, where do we want to look? Do we want to look here or there? I think this might be nice actually as a position here. But in order to Easy. Yeah, that's what I thought. See, we are directly going through the thing, which we should not. So let's do something like this. 001. Apply current value. But we should keep the height constant, or the focus point. So the focal point is that one here. We keep that here. And now let's see. We look at this stuff. Ooh, that's bad. That's bad. That's bad. So this one will be 0.3 here. 0.15. We will duplicate that one and put it to 0.45. 0.7. And let's see. So we start here. We go over here. We look in here. And we move out. We skip that one here. Right? This will be really fast. So we should maybe slow this down. We just make it like 10 seconds. And then it should be good. Oh. My computer's running wild because it's constantly loading a new state here. It's like a little bit offset. So maybe we can put this more into the center. So if we have this and we want to look at the center more. Should be. Okay, we need to rework this whole. So let's first say we are looking at some point like that. Our height is 186. That's fine. Oh boy. 186. And this position is 038. And the X position is minus 141. Okay, does this still... What the hell did I do now? And I screwed up. So oh, oh, 1. We are doing this all over again. 185. Okay, this did not change anything. That's very, very good. 138. Let's do it 139. Let's decrease the height a little. What happens if I go here? Yeah, that's fine. That's actually fine. So 184 we are looking at. And this one's going to be 035. And this one's actually going to be 120. Right. So we want to look. Nope. Wrong direction. Wrong direction. 3. Yeah, that's fine. That's fine. That's fine. We're saved. So if we try to keep this one here, apply current value, and we say we want to paste the focal point here. How will it look? My focal point is way to the left. So let's see. How can we change this? So 184. Height is untouched. 3. Oh boy. Okay, so we need to look at this. What's at minus 110? Are we looking in the middle right now? Not even. So 09 it is, maybe. Okay. That's more like the middle. So we can keep that here. So we paste that here. And we can paste that here, maybe. Maybe here. And maybe here. So let's see. That works beautifully. And we zoom out. And we need a higher focus point for the end scene. 25, something like that. Which one was my total view? I just paste this one here again. Okay. Yep. We can look at this and go out again. Yeah, I think that will work. That should do the trick. Okay. Yep, that's fine. Let's keep it like that. I love it. In the end, I will have to make the decision whether we want to have the pink cylinders in here or not. But let's keep it in for now, like that. I'm happy. I will put this one on the cluster and let it run for a little so I can record some history. Thank you for watching. See you next time. Bye bye.